and welcome everyone to episode 24 of the IT India Digital Conversations. Way back in 2015, the GSMA Wireless Association defined a series of LPWAN technologies, or low power wide area network technologies as we call them, like LTE, NB-IoT, LoRa, and Sigfox, to help network operators meet specific cost, coverage, capacity, and power consumption needs for IoT applications. So that is what we essentially discuss today. When we talk about LPWA network shaping the future of IoT, but the discussion is paramount not only because it's about how it increases the capabilities of IoT, these kind of technologies, but also because not too often you get a chance to host a set of industry mavericks who represents a topic in its entirety. And I'm sure we'll do justice to the conversation today. Now, I would request you, Sunil, to take the screen and start the session today. I, meanwhile, shall remain hidden until you guys need me. Over to you, Sunil.
Yeah, thank you so much, Suman, for that introduction, and good afternoon to all the participants who have joined us virtually, and a warm welcome to all the esteemed panelists. At the outset, I would like to thank IET for giving me the opportunity to moderate this panel with industry stalwarts to discuss and deliberate on a very, very valid and pertinent topic, how the LPWA networks are going to shape the future of IoT. The National Digital Communication Policy in 2018, that was at least 2 years back, one of the objectives of that policy was for India to have about 5 billion connected devices by 2022. Because of the COVID situation, we might probably run into a challenge in terms of meeting that number, but a huge percentage of that growth is definitely expected to come from the LPWAN networks. Now, when you talk about IoT connectivity is the backbone for any IoT solution, right? I mean, you can a best possible platform, but if you do not have reliable and secure connectivity, obviously a solution is not going to work. And there are various factors that consider when choosing the right IoT connectivity solution, right? Because there are various factors that one need to consider when choosing the right IoT connectivity solution. The first thing, of course, being the bandwidth capacity, the volume of data that you're going to send between devices, from the device to the cloud. Coverage and range, very, very important. The power consumption, and we're going to debate a lot on that because each connectivity solution have different power consumption requirements. Cost is obviously a very, very important factor. Your network data plans, the cost of devices, that obviously plays a big, big part in that. Your integration into your back-end existing environments, your IT environments, I think that also is a critical factor when you have to choose the right IoT connectivity solution. The place of deployment, another very, very important factor. Where are you going to deploy that solution, especially if you are going to deploy it in a place where there are a lot of walls, a lot of radio interference, or at places which are in basements, subterranean buildings. There, of course, certain LP1 technologies work well. Maybe traditional cellular may not work well there. And of course, a very, very important factor being scalable, right? I think the need for the solution to scale, that becomes very, very critical when you talk about choosing the right IoT connectivity solution. Now, there are multiple options for IoT connectivity, right? We've traditionally been using cellular, right? And cellular, by and large, is I would say most research suggests that more than 50 to 60% of connections that are deployed today is using cellular today. But that might definitely change with a lot more adoption of LPWA technologies. You could also use Wi-Fi. Wi-Fi 6 apparently is very optimized for IoT. You could use short-range networks like Bluetooth, low energy, or mesh networks like Zigbee, Z-Wave. Satellite, there are use cases where one might use satellite, especially if it's in very remote locations, or even in use cases when you're moving cargo, from one continent to the other. I mean, from the high seas, satellite becomes the best option. And friends, LPWA, and Jim will probably later cover what are the differences between LPWA and other options. But we're going to obviously debate a lot on LPWAN and how it's going to shape the future of IoT. And each connectivity solution, it kind of offers a trade-off between bandwidth, coverage range, and the power consumption, right? So you could perhaps use cellular and satellite if it's requires high coverage, high bandwidth, and high power consumption. You could perhaps use Wi-Fi and Bluetooth if it's low coverage range, high bandwidth, and low power consumption. and perhaps LPWAN if it's high coverage, low bandwidth, and low power consumption, right? So depending on that, you can choose it. There are enough and more use cases today where one can deploy LPWAN, right? I mean, whether it is asset tracking, condition monitoring, smart metering, and we're going to hear from Gaurav and Ali in terms of what are the use cases where they have deployed these kind of solutions. And more recently, we started to see how LPWAN has also been used in the COVID scenario, right? And I guess even Ali can perhaps throw a little more light in terms of what Sendra has been doing in that space, especially in the last 7-8 months during the COVID situation. The format is very clear, very simple, friends. What I'm going to do is I'm going to ask a couple of questions to each of the panelists, and we hope to finish by around 3 or 3:05. And at around 3:05, 3:10 is when we'll probably open it up to the audience for questions. So that's the format. And let me first start by inviting Jim. Jim, thank you so much for joining the session. Firstly, I would like you to, at a very high level, cover what would be the key differences between LPWAN and other traditional options from a connectivity standpoint. And then you can perhaps share some trends in terms of how do you see the LPWAN adoption happening, not just from an India standpoint, but at a global standpoint, Jim. Over to you, Jim.
Sure, thank you, and thank you for that introduction. Now, I have actually prepared some slides brought in line with these, with those questions. So let me just address the technology and share a screen. So hopefully, I'm now sharing a screen. Can you see my screen?
Yeah.
Excellent. Fine, thank you. So I'm Jim Marsh, founding partner of Transformer Insights. This is a few very quick slides just to take you through just an introduction to LPWA and to frame some of the subsequent discussion. So I'm going to stay at a fairly high level here. Firstly, if I can get this thing to, there we go. So firstly, what is LPWA? So from a technical perspective, Sunil's already mentioned some of these things, but just to be clear about them, from a technical perspective, the LPWA devices, the critical differentiating factor is that they have low power requirements. So we're talking about devices that you can deploy in the field and potentially have a battery life of up to 10 years. That's an incredibly impactful thing, and it means that you can have a sensor which has no need for a power supply, and you can deploy it somewhere and it'll work there for 10 years and send signals back for that period of time. Now, there's compromise there, so if you communicate more frequently, it shortens the battery life, but there's a particularly great potential there unlocked by that low power requirement of the end devices. Critically, these connectivity technologies also support wide area connectivity, and what that means is that coverage can be assumed. It's not like a Wi-Fi device where you're trying to use multiple individual private networks. This is a wide area. It could be a nationwide or potentially citywide or campus-wide, depending on the kind of deployment. But once you've deployed the network, you can assume that it's there. So you put a device somewhere, and it'll connect to that network, which, as I say, could be a nationwide network. As Sunil has already suggested, there's a strong link budget. So LPWA technologies are particularly well suited to penetrating in buildings or in places that are difficult to get. That's critical in IoT because water meters and gas meters and electricity meters may not be located in places that are ideal for radio communications. So you want to be able to reach them where they are, and that's a big challenge. Which LPWA helps with. They're low cost, so it's cheap to set up networks. The cost of setting up for instance, a LoRa campus network is negligible. The cost of deploying NB-IoT, well, there's two types of deployment, but just deploying it is really quite cheap across a national network. Upgrading it to ensure great power consumption costs a little more, but it's fundamentally a low cost thing. And with Sigfox, you have the same dynamic. So very cheap to set up networks. Devices are low cost. The traffic costs are low. Partially that's because there's so little traffic that the traffic costs are low. And for instance, you have companies like Once. That's the number one, and then the letters NCE, is a European company. In fact, it's associated with Deutsche Telekom in Germany and Europe. They'll offer connectivity for €10 for 10 years. That's incredible for wide area connectivity across multiple countries as well. So that's a remarkable proposition, I think. Low bandwidth. So the trade-off for all of these benefits is the low bandwidth potential. You're not going to be streaming video over LPWA connections. That's not what they're for. They're for something fundamentally different. But with just a few bytes, you can get a meter reading, or you can know that there's a problem with some infrastructure, or you can know that an emergency heart recovery device, the case has been opened and therefore it needs attention. You only need a few bits of information for that, and battery power and 10-year lifespan make that a very suitable proposition for LPWA. So you can do a lot with a few bytes. On the right hand side, application perspective, what can you do with it? Well, I've started talking about that a little already, in fact, but there are many tracking solutions, tracking of pallets and distribution cages and even individual packages now, and you can monitor infrastructure. So monitoring bridges for vibrations. You can deploy a vibration sensor to a bridge with a battery lasting for 10 years, and you can just deploy those across a bridge. And if there are any abnormal vibrations or any significant vibrations, you can get a signal from that remote device, and that's really quite an impactful new application of technology. There are also trigger devices, so just knowing if something has been used, if a case for a life preserver at a harbour site has been opened, you can get that information back. And disposable devices is an interesting one as well. So this is something which in fact Sigfox has done with the honourable Indian company Jaguar Land Rover, formerly a British company, of course. And what they actually did is some direct marketing, and they sent out direct marketing packs to potential customers, and the customer would open the direct marketing pack, and there was a little ignition button inside the marketing, and they pressed the button, and that set off, as it was connected by Sigfox, and it set off a sequence of arranging a test drive of that vehicle. So that really is direct response. You open the mailing, you press the button, and there's a Sigfox connection that knows that you now want to arrange a test drive. Very compelling. There's also things like disposable labels, even, which are supported by NB-IoT with Vodafone and Bayer. In fact, so that label tracks an individual parcel through a supply chain, and then when it's opened, a circuit is broken, and you know that it's been opened. So that's actually a disposable device. It's that cheap. So many new applications are viable. Because of these new technologies. You also have volumes increases for some applications. So for instance, tracking of children or assisted living applications, these could work with non-LPWA technologies, and they do work with non-LPWA technologies, but LPWA makes them work better at a lower cost. And that increases the market size for those applications. You also have some technology displacement. So, for instance, power line communications in the case of smart metering, that's something which, to some significant extent, is going to get displaced by LPWA, and probably it's most likely NB-IoT that's going to have the biggest impact on PLC in a smart metering context. So there is some technology displacement, but there's significant opportunities here. If I move on to the next slide. History of LPWA. Well, the LPWA space started in 2013. It was in fact identified as a group of technologies, and the potential opportunity and impact of these technologies was in fact identified by myself, and LPWA was named by me back in 2013. And before that, there was a number of disparate players who all had interesting, innovative radio access propositions, but it hadn't been pulled together into a market, and it began to move at around about that point, some quite quick development. So one of the significant ones, which was founded in 2010, was Newell, which was the weightless technology, and that was acquired by Huawei in 2014, and that's what then became NB-IoT. It was a significant contribution to the 3GPP standards, which eventually became NB-IoT. LoRa Alliance was founded in 2015. Ali will say more about that later. The first NB-IoT network was launched in 2017, but that was actually pre-standard. The standards were finalized, but the network wasn't quite reflecting the latest standards. That was a very early launch. So that was 2017. 2019, by the end of 2019, we have 100 million LoRaWAN connections out there in the world, nearly 100 million cellular network LPWA connections. So there's a couple of 100 million connections at the end of 2019, and I would have said at the beginning of 2019 there was probably more like 40 or 50. So it's a very quickly growing market. Looking forward to some forecasts now and the future. These are based on Transformer Insights forecasts, but we think that by 2026 there are going to be more LPWA connections in the world than there are cellular connections in the world. So non-LPWA cellular connections in the world. So 2.18 billion versus 2.17. By 2030, there's going to be about 4 billion LPWA connections worldwide. How does that break down? Well, again, these numbers are from our forecast. And on the left-hand side, you've got numbers of connections in 2013. You'll see that India we're forecasting to be the third largest market worldwide for LPWA as a whole. So very significant opportunities in India. China's leading. China's definitely leading today, and that's because of the NB-IoT Huawei connection. It's become a strategic imperative for Huawei and the Chinese government to push ahead with that, and that they are ahead of the rest of the world at the moment on NB-IoT. The rest of the world will catch up, but they've made a decision to push with it. And also they just like to monitor more things in China. So India is the third largest market. Many markets worldwide are very significant. All of the all throughout Europe, USA, etc. So a lot of opportunities worldwide. What about the vertical split of these LPWA connections? And this is on the right hand side. This is the vertical split in 2030, and it's worldwide. So it's a worldwide split, not the Indian split, which I'm showing here. So about 71% of LPWA connections will be enterprise in some way. The remaining 29% will be consumers. So that's things like child tracking devices or assisted living devices. But about 71% are enterprise. That's a lot. Quite a different profile from other forms of wide area wireless connectivity, where there would be many more consumer users than there would be enterprise deployments or enterprise endpoints. So much more skewed towards enterprise. Roughly 20%, 20.5% of these connections are cross vertical. So it's things like environmental monitoring and trace of assets, which could be deployed across many sectors. Within the sectors, the largest sectors are oil, gas, steam, and water supply. That's smart metering. But you've got many other areas. You've got things like transportation and storage accounts for a significant amount. There are many administrative things, government applications, health and social care applications. So there's a very fragmented and wide range of applications there. And that's the end of the slides that I wanted to show. And really, just what I wanted to say now is what about the conclusions for India? I mean, we've seen that there are very significant opportunities worldwide and for LPWA, and the same happens with India, particularly in a smart city context. I think it's such a big country. It's easier to start off in a smart city context. I know that smart cities is a strategic focus in India anyway, and there are many things that can be sensed in a city environment, and through to things like parking management and things like that. Supply chain tracking is going to be a very significant opportunity in India, again due to the distances and the fragmentation of industry. It's going to be a very significant opportunity. Smart metering, of course, will be a huge opportunity. One particular thing to call out is the license exempt opportunity. I mean, we have Tata and Senra. Those are two very significant LoRa players in India. frankly, they're also very significant on a world stage. They're two of the most significant players in the world. So it's worth noting that India as a country effectively has that asset. Sigfox, of course, also present on this panel, and I know rolling out in India, and we'll hear more about that later. There are also opportunities in licensed solutions, particularly to support global solutions and supply chains and end users that want that want connectivity in India and outside of India on effectively using the same solution. So in the IoT and LTEM, the licensed versions of LPWA are very suitable there. One thing I would say that is an opportunity for everyone associated with the LPWA industry in India is the concept of Gandhian engineering. So more from less for more. And when you've built something that works in India, many of the business cases that stand behind those solutions are based on displacement of labor costs and the lowest available labor costs effectively. So once you've got a solution to work in India, it's going to be attractive in many export markets. So there's a significant export opportunity around this. And with that, I should draw to a close and say thank you again for the introduction, for the invitation to speak, and I look forward to hearing our other panelists.
Thank you so much, Jim, for firstly sharing the attributes of LPWAN and also some of the trends that you're seeing. I just have a quick question to you, Jim, in terms of one of the slides that you presented. I think you forecasted that in 2026, we'll probably see the number of LPWA connections overtake the traditional cellular connections, right?
Yes. Yes.
Now, would you have a split in terms of within LPWA, how much is licensed and what will be the percentage of unlicensed? Will unlicensed LPWA be overtaking the licensed one, Jim, as per your forecast? Thank you so much, Jim. Now we move over to Sarojit Jha. Sarojit, welcome to the panel. Now Tata Steel has deployed one of the largest LoRaWANs in India, and we're going to hear from Sarojit about this whole deployment, share some of the use cases where Tata Steel have deployed their solutions. He's also going to show a short demo, right, Sarojit? So Sarojit, over to you. Looking forward to hearing.
Thank you, Sunil. Welcome everybody. Great hearing you, Jim. A few quick comments on me. I think you've heard about the technology. You've heard from Jim that if you can make a use case work in India, then the cost structure that you're making it work, the tough terrains that you're making it work, the lack of connectivity that you're making it work, makes it a very, very attractive business case to take to the rest of the world. And in terms of the overall business case to make something work, I believe that any technology to work needs to have a global business case. And when I say that, let me explain that. AI, the business case is very clear. Data is becoming very cheap. Computing power is becoming cheap. Algorithms are becoming better. So AI has a very strong global business case. Cloud has a very strong global business case, what we like to say as safer, scalable, agile, flexible, efficient, and relatively risk-free. Blockchain, for example, in our view, does not yet have a global business case. Many of the things that blockchain can do are being taken over by other database capabilities in terms of permission hyperledger. Coming back to this, the industrial, what we call the industrial Internet of Things, and which is a part of the Internet of Everything, has a very strong global business case, particularly in aiding what we call as our scale model for AI. And when I say scale, I mean sensing, which is actually knowing where things are, where people are. It is about comprehending, which is the intelligence of the AI. It is about two-way systems of communication where you can act. It is about learning so that you're efficient with the knowledge you already have and you make the best use of the data that is available to you. And finally, experiencing, because we believe that everything will ultimately go into the Internet of Senses. So I think at this point of time, if the video can be played, it would be very good, where some of these kind of woolly concepts that I just outlined will become very real and hit terra firma. Just to give you a background, so I think this has an audio.
Hello, this is the landing page of the connected workforce system. So this is a real-time dashboard which shows how many registered active employees are present across all the locations. So employees basically covers the non-OPR segment and the contract workforce. The second box that indicates here is the number of people who have already swiped in across all the locations for Tata Steel. The third box is specific to Jamshedpur plant, where how many employees have entered the premise is shown as in the number. Finally, it also shows the number of Suraksha card distributed across all the plants of Tata Steel in India. Further down, you get to see a geo map of India, and the numbers of employees in various locations are indicated as red circles. If you further click on any of these circles, you will reach to the exact specific mill or the plant which is continuously indicated as a circle. If you hover your mouse on any of these circles, it would show an aggregated number, and the list of all the plants and the mills are appearing here, against which the number of people who are there at this point of time is also shown. So let me reach out to one of the specific example which I would like to demonstrate here. So in this particular case, I'm interested in how many people are there for hot strip mill, which is HSM plant. So 453 people at this point of time is there in hot strip mill. If I further click on this circle, the plant layout opens up. This plant layout is divided into two different zones. So the subdivision of these zones are indicated in two different colors. One is in the blue colored boxes and the second is the red color boxes. The red color boxes are the ones which are high hazardous zone, and the blue color boxes are the ones indicating the low hazardous zones. All these numbers appearing in these boxes basically indicates how many people are there in the specific zone at this point of time. So if I click on one of these zones, which is C3CDL, it shows me that 4 people are there at this point of time. On clicking of that, it shows me the names of all the 4 people, who is the specific vendor for these contract employees, what is their employee ID, what is the last time when they were seen, or rather what is the last time when the data was received from the Suraksha card. So if I further want to look at the specific tracker of this individual, so let me click on Mr. Malay Mandal. Once I do this, a personal tracker for Mr. Malay Mandal opens up. So the screen is divided into two parts. On the left hand side, you get to see the personal and the professional details of Mr. Malay Mandal. For example, the safety pass number, the gate pass details, the mobile number of this gentleman, the vendor under which he belongs to, and other informations. On the right hand side of the screen, there is a red dot which indicates that this gentleman is in HSM plant, like we already know, and the last information that was shared from his Suraksha card was at 9:41 a.m. If I further click on this red dot, the mill layout opens up again, and it basically indicates where he is exactly at this point of time, which is at C3CDL zone. And this is the same time when the last information was shared by Mr. Malay Mandal. Further, if I click on zone movement, the entire day zone movement is indicated here. So this basically shows you from where did this Mr. Malay Mandal entered. He crossed through certain mills, other mills. He might have stayed in other mills for certain duration, eventually reaching out to HSM plant. So the sequence of the events are listed here. The time is also listed here. When was he seen in that particular area? So the first entry point into that mill or into that zone is indicated here. At the last, he was seen in the HSM plant, which is exactly how we traverse through into this page. And eventually, if I click on this blue pill, you will get to see the movement of Mr. Malay Mandal inside the HSM plant as well. So the sequence of event was something like this. So that's
Alright,
how
so
one can track the individual person's entire day of movement. This also is helpful to identify whether or not he's in the right zone, whether or not he's in the low hazardous zone. He should ideally not be in the high hazardous zone or some no entry zone.
So you just saw that was a live version when it was recorded. It allows us to know exactly where 60,000, 70,000 people are across some of the most remote parts in the world. Those are naxalite areas. They're some of the most backward areas in the world. And we have some of the most forward deployments, as you could see, in terms of what technology can do. The way we got this done, I will get an architecture diagram put up, please, Sunil, if somebody can help me with those two slides which we have. In the meantime, the net takeaway of this is that we need to first focus on the use case, which is the business rules and the business logic from where the business viability comes from. Then you need to have the user lovability and the ability to use, which is where what people, is the card small enough, does the device have battery life, will it get picked up? And then you need to look at the technological feasibility rather than jumping into the technological feasibility first up. And just to have a few bragging rights on the technological feasibility, we have 19,000 beacons which are beaconing at 100 milliseconds. We have got 70,000 of the Suraksha cards which are catching them at 400 milliseconds. The entire polling takes about 45 seconds, and we get to know in a minute's time where the person are. So the lag is about a minute. You can bring down the lag, but that kind of accuracy does not really add any much value in our view. And then you have a quick emergency response team. If the person either presses the button that he is in danger, or we pick him up in a hazardous area, there's a lot of AI which is being used, because the total potential of this is we are processing about 163 billion records in milliseconds. And the kind of false positives that you can have can really swamp you in an industrial network of, when it's spread over, about 25, 30 square kilometers. And it's very, very essential that we take care of that. A couple of important points on technology deployment, if I may. One, technological feasibility is very essential. Two, it's a combination of the technologies that work, and it's not one technology, in respect to another. Three, you need to have sure that Indian bread, as we call roti, the return on technology invested is absolutely taken care of. And I think once my slides come up, I'll show you some of the overall things that are there. Fourth, on technology, you need to have a point of departure and a point of arrival very clearly laid out in terms of your technology architecture, and this needs to be a living document which is 80% fixed, but 20% all new opportunities which are coming up as different technologies go. And last but not the least, in 2017 January, Jamshedpur was probably the first town in the world, definitely in India, that became 7-walled LoRa enabled. We have the ability to take it to 11-wall LoRa enablement if we so desire. And as Jim said, Tata Communications is a global powerhouse in this space, and they are the ones who are providing us all the backend as well as the backhaul. But you can see the slide that ultimately everything is about the user. I think it has to be about stakeholder experience. It cannot be about technology. It cannot be about business concrete. And the way we look at technologies at 3 layers, we look at it at the infra layer, and that is where the network, the connectivity, the cybersecurity, and the cloud comes in. We are one of the few companies in manufacturing that are 80-85% on the cloud. We're running some of the largest S4 instances anywhere in the world, definitely in Asia. We have about 400,000 sensors, data from which we need to collect a very strong L1 and L2, level 1 and level 2 systems. About 100 AI-enabled models. I think the number is now 200, which are running on top of it. So it's a very complex technological deployment. It's against a plan. But all of this technology has only one function, which is to sense the environment, whether it's people, it's process, it's operations. We have a 6-node connected philosophy. We call it the connected worker, which you just saw. We know where the workers are, how they are, whether they are in hazardous zones or not, and that can be extended to productivity as well. We have connected assets, where more than 2,000 of our critical assets have been put into predictive asset maintenance, again using Internet of Things really. We then have the connected operations, where all these AI ML models are making sure that the operations can become as autonomous or as much of smart assist as possible. We primarily believe in smart assist, which is being backed by this. We then have the connected customers, where we have platforms in the marketplace, not really significant for this discussion. Then we have the connected transactions, where we have taken all our transactions across HR, uh, procurement, finance, and we are putting it into a business process as a service model completely. And then we have the connected decision making, which is run by a process called integrated margin management, where all decisions can be taken simultaneously in impact. But coming back to this, we are now looking at the connected data part, which is the line that connects everything together, and that is where a single version of the truth has to be established. And I think that is where all the different uh, platformatization sits, as we call it. And I'll have in the next slide some of the principles of platformatization that allows us to make the security against it. And as you can see, we looked around and said, we are talking about platformatization as a journey. We are building about 8 to 10 platforms internally. But how do we know we are on the right track? And we found that we didn't really find a very compelling story of how to measure a platform, let alone deliver it. I mean, software companies would have it, maybe obviously the tech giants have it, but what about us as an industrial company in the eastern part of India? How do we kind of go around the platformation journey? So we came along with what we called our script. It's very simple. It's open, which means that we should be able to be device agnostic, technology agnostic. We should be able to bring in the best of breed and have rip and replace technology capabilities as necessary. It should be scalable, which means that the marginal cost of onboarding anybody into the system should be zero or close to zero, and ideally should give us positive benefits because of network effects. Connected, so seamless people to people, machine to machine, and people to machine connectivity, which is what you saw. We know the equipment, we know the geospatial tagging, we know the person, we can get all of the data we want. It obviously has to be reliable because ruggedness is very important. Some of those places have very harsh conditions. And on a lighter note, I'm very fond of saying this, that every day at least 10 sensor partners get in touch, and by the time they come into the 1600 degrees centigrade heat 250 kilometers from Jamshedpur, their material as well as the spirits kind of vaporize, and then they can come into Jamshedpur and enjoy our hospitality in terms of lighter spirits. It obviously has to be intelligent because you can predict and recommend. You need to be absolutely clear that it's about insights that are delivered near real time, insights in the hands of the decision makers to make the best possible decision. That's where all the value comes from. Personalized. It has to be profile based dashboards. It cannot be two people's requirements are not similar, so why should their dashboards be similar? And last but not the least, when we talk about technology, we really talk about IT and OT integration, because you saw the layers in the last slide. The bottom layers were all OT technology, and then you only have a single demilitarized zone because you need to be secured and you need to ensure that all the data goes in one place to give you the single version of truth. The upper layers that you saw in the last slide were the consumption layers. The first consumption layer, as you can see, is analytics and insights. There is over that sits the artificial intelligence. Whatever human models cannot do very easily goes to artificial intelligence. It can also be taken in reverse. And last but not the least, you have the visualization layer, where ultimately seeing is believing and believing is doing. So that's how we got here. And one of the things that so if somebody were to ask me what are the 5 things that you want to take away from this journey, I would say that any transformation journey has to be leadership driven and business led. So the ownership of all of this is business. IT just plays a supporting role. We just make the technology available, but the use case is that of business. Value comes from business. Second is focus on the data. Data is the number one asset. I don't like data as the new oil, because then you will store it and have a huge cost in it. I like to call upon data as the new sunlight, because you can make number of copies on it, and my consumption is not reduced by your consumption. If at all anything, it's actually enhanced. The third thing that I would say is that you need to focus on talent. There is very specific talent, and there is 100 and 1,000 talent, and all of that by definition will not be inside your organization. So you need to reach out to ecosystem partners who do the job. And one of the questions I come from the outsourcing industry for a while, and I used to ask our own team a question. And you go to others and say that your gutter is my butter, and take it, but where is your gutter and why is it not the butter for someone else? You end up doing everything all by yourself. And after that, you need to make sure that the data supply chain actually has got the O script principles that I just come into it. And last but not the least, what got you here will not get you there. So how are you writing your next script? In fact, this particular script has run out of course. We are already writing our next script, which is all about startups for speed. It is all about cognitive, as we want to become an anytime, any place, anywhere human machine or human or cyborg agnostic organization. R now stands really for responsiveness with resilience. I stands for innovation. We need to do much more with much less. P stands for platformatization. There are 8 to 10 platforms that we want to be a platform driven company. Everything should be in a platform, all syndication through the platform, not through the human processes that have made us a Deming company. And we are very proud of that, of course. And T, of course, stands for talent. They're going to take us to the next generation. So over to you, Sunil. That's all I had from my side. And thank you very much for a patient listening.
Thank you so much, Sarajit. Fantastic insights. The script framework that you talk about for embedding digital transformation, I think that's a fantastic framework. And I think Tata Steel is perhaps one of the very few companies in India fairly mature when it comes to adoption of digital transformation. And I'm sure this journey will continue well. One question, Sarajit, and since the topic is about LPWAN networks and how it's going to shape the future of IoT, for any of the use cases that you have deployed, and when you'll have to choose between the various connectivity options, and specifically here, LoRaWAN, what were the various factors that you took into consideration before narrowing down on the right choice, Sarajit? If you can explain to the audience.
So it's okay. This is the way we look at it. The first thing we say is what is the use case and what is the payload of data, that the minimum viable data that will do the use case. Then we look at the latency. What is the maximum latency that I can tolerate for any polling use case? Then we look at the device. What is the ruggedness of the device and what is the battery life of the device? And the battery life of the device at two levels, which is what is the battery life if I were to make it passive and what is the battery life if I were to make it active. Then we look at the overall network design. What is the minimum number of polling agents and what is the minimum number of catching agents? We have a pitcher and catcher concept that we look at. Then we look at what is the shadow areas of the mix between open areas, closed areas. Then we look at, do I have an XY configuration to do it for me, or this Z dimension, which is a killer, comes into play. Then we look at the fact that is it that I have a mainstay, kind of a lead use case, but are there other use cases that at some point of time will jump into it? And then I look at, are those use cases going to make this viable, or are those use cases unnecessarily going to slow me down, in which case I'll have 1 unhappy customers and 5 wandering customers. And then we look at into the fact saying, is this an area specific which it will do it in the mines? Can I run it in offices? Can I run it in my factories? What about indoor versus outdoor, which I talked about? And once we do that, then we always have a belief that it's always a combinatorial ones that work. What is it that should be? And fundamentally, then we take the edge versus cloud decision in all of this. So wherever the intelligence, wherever you need to bring analytics to the data, we say this has to be at the edge. So unilateral upper control limit and lower control limit led decisions. Whenever we need to take the data is so large, the analytics is so complex that you need to take the data to the analytics, and the latency is acceptable. Then you take the data to which is where our cloud comes in. And so any decision on IIoT is not divorced from a decision on edge versus cloud, and of course all the other things that we talked about.
Thank you, Sarajit. So there's this whole cliche which you said, data being the new oil and which needs refining, and you came up with data, the new sunlight. So okay, well, let's move on to Gaurav now. And Gaurav, my question to you would be about Sigfox has been in India for some time now, right? I think 3 years, if I'm not mistaken. So if you can share with us about your operations in India, a few use cases where you have deployed your solution, and I'm specifically wanting to understand why choose the term 0G network. You have 2G, 3G, 4G. So what's the significance of what is called as the 0G network, Gaurav? you can explain for the benefit of the audience.
Sure. Thanks, Anil. Firstly, thanks for inviting me to this really esteemed panel and informed talk. I fully concur with what you and Jim were talking about earlier, and you set the context really well for LPWA, starting with the evolution and how it has now come to a level where wireless sensor networks is going to drive the future of machine-to-machine communication. Typically, when I talk to audiences, I like to start there and map it to the technologies that we understand and we know, and which we've been using all along. However, despite it being having lived online for the last 25 years, we still forget that there are a couple of very interesting facets of the internet which essentially make it very, very compelling and have led to its prolific demand. And I use that analogy to map it to where we will go in the future. But you guys did that ahead of me. But so to just take a cue from what Jim mentioned about that LPWA networks and demand would come from for this new digital transformation will come more from the enterprise realm as compared to the consumer realm. And that statement is also undeniable if you look at the user experience in the enterprise realm versus in the consumer realm, and all of us recognize that the user experience in the enterprise realm significantly lags behind the user experience in the consumer realm. So Sigfox 0G is essentially conceived around the future enterprise, which we firmly believe will be built around an untethered infrastructure, which will be a combination of communication technologies that utilize licensed, unlicensed, shared spectrum assets, and essentially leading to the creation of an unbounded enterprise where the limitations that are currently exposed or imposed on the physical assets and goods production, the traditional OT part of the IoT has been not brought into the IT realm, and so that is where we believe that IoT and smart devices that automatically learn, understand, and adapt to the constant changes in enterprise operations, supply chain, product performance will drive the usage of LPWAN, right? And of course, all of the idea is to actually be able to acquire data at the lowest cost from objects that were physically or previously outside the scope of connectivity and the internet and the web, and that is where we believe that the second coming of the web, if you will actually imply that tiny, almost free sensors will get embedded into much of the physical world objects that we see around us, whether man-made or natural, right? And that's what will lead to a massive demand for special types of networks that would require the likes of Sigfox and of course LoRa to become relevant, right? In terms of 0G, a little on that, Sunil, you asked that specific question, and that stems from our founder's vision, Ludovic's vision of what he believes Sigfox to stand for, which is a global, reliable, and simple network where time to market, cost, reliability, and operational simplicity will drive market success, will determine market success, right? And the way we are achieving that within Sigfox and the 0G network is by improving the maturity and discipline in operational processes by having actually one global community of about 75 odd operators as on date to pool in their know-how, their expertise, and their understanding of the market conditions and the use cases that they're growing and developing in their own markets. And that is a huge paradigm from the way we've been looking at developing businesses in the past, which is to look at regional use cases, to look at regional opportunities, and build ecosystems to support them. Whereas in the Sigfox world, we've kind of lifted that problem and made that a little bit where we get the economies of scale to drive down the barriers to entry and also the costs of adoption, if you will, right? And we have now come to a stage where we've moved from network operations being the innovations bottleneck to one in which they have now become the competitive differentiator, right? And that is where our public network philosophy of actually providing ubiquitous public network for a diversity of applications to freely exchange data bidirectionally has paid rich dividends, right? And we've seen in other markets, and that's what we hope to see in India as well, that the killer apps, the services that you will develop around this infrastructure, this public infrastructure, would automatically be funding itself and in rapidly densifying that infrastructure. And how do we at Sigfox have accomplished this? Is of course through going a layer below and above what we typically offer. So what we offer is of course the connectivity protocol that will allow you to build really low power, low cost devices and be able to exchange data directly with the cloud. But also we've now gone and syndicated with module companies and device companies, and we do our own very stringent certification for devices and before we certify them as Sigfox ready, which means that when the customers deploy them in the field, they're expected to come with a seal of authenticity and quality that Sigfox stands by. And as you can see, we have now recently tied up with some of the largest device OEMs in the world, Alps Alpine in Japan being a case in point, where we are significantly investing a lot of effort in strengthening that part of the ecosystem, because we believe that until we have very reliable, very robust, very strong device ecosystem which has the ability to manufacture and handle the operational processes for hundreds of thousands of devices, we would not be able to succeed in delivering end-to-end solutions. And so through a combination of modules, devices, a public network, platform and applications, we are actually bringing the ability for customers in different applications, and I'll talk about what specific applications in India in a minute, but in different applications to embed very useful intelligence into existing processes, right, which can help these enterprises, these customers, boost their effectiveness to whole different levels, right? So that's what our vision and our aim is in terms of the Sigfox network deployment in India, and the way we are envisaging the market to develop. Right now, a very interesting point here is, if you looked at 10 years from today and you tried to predict what this new Internet of Things or Web 2.0 would be, right? You could question, right, that anyways we are living in such a heavily congested digital world as in today, and what will be different? But wait till we get to the point where we see wearable contact lenses and move on to the more esoteric avenues of alternate reality, etc. And that is where all of us would probably look back and said, look back at this time and say, only if we had realized how possible everything was back then in terms of being able to add intelligence to existing devices. So in our opinion, also what we are seeing is that in order to and the way we see Sigfox is actually as a zero-G network is a very cheap, powerful, and ubiquitous AI platform, right? And what AI for us is essentially the ability to embed the fundamental intelligence in the natural or the physical world to answer two questions, right? And those two questions being how am I or condition, and where am I or location, right? And so that is where we believe that we will do our bit in developing this infrastructure in a way that we can offer a platform for AI for a host of applications. Right now, I'll come and spend a few minutes in terms of what our focus for India is and what we believe our strategy for network deployment.
Gaurav, just hold on. We'll probably in the second round when we talk about India specifically, maybe you can at that point in time talk about India. I just one comment, Gaurav. I think you mentioned about the fact that you'll have your devices certified and you're trying to expand your device ecosystem. I think that becomes so crucial, right? Given that sometimes the device becomes the weakest link in the whole chain, and the fact that you need to have the certified devices.
Absolutely.
Just one quick question. You have about 72 odd countries on your network now, right, Gaurav?
That is correct.
What are the plans?
Plus the additional ones that have not been publicly disclosed, but yes, that number is correct.
Okay, great. So I'll come back to you, Gaurav, when you talk specifically about India. We now move to Ali from Sendra. Ali, over to you. If you can share firstly about the LoRaWAN Alliance and also share some use cases where you'll have deployed solutions in India. And Ali, if I'm not mistaken, I think when the pandemic hit us, I think if I recollect, Sendra were actually offering free LoRaWAN solutions for certain use cases, if I'm not mistaken. Am I right, Ali?
Yeah, we made it basically to the end of the year free connectivity of LoRaWAN network services for people deploying COVID-19 LoRaWAN solutions.
Fantastic. Over to you, Ali. You can start by talking about LoRaWAN Alliance.
Hi, everyone out there. Thanks for having me, IIT. Sunil, thanks for hosting this and being the moderator. You guys have heard from a plethora of experts on the panel related to LPWAN technologies, real-world field deployments. I come from the LoRaWAN perspective of the overall arching LPWAN technologies. I am an ambassador for the LoRa Alliance. I'm also the CEO of Sinra, which is a public network operator in India deploying LoRaWAN network services. So LoRa, as Jim mentioned, LoRa Alliance formed in about 2015 with some core members that were deploying LoRaWAN technology in Europe and North America. And it has rapidly grown since then. What we've seen now I think my numbers are based off of start of second quarter this year, but we're over 500 members. And what that means is companies around the world have joined the LoRa Alliance's organization to contribute to the standards and specifications of the technology, the growth of the ecosystem, as you heard from Gaurav, related to the device ecosystem, all the way up to the analytics and the applications and everything in between. So you've got members such as Amazon that has joined. You've got big SIs that are starting to join, like in the retail space, there's Target that just became a member. Tata Communications Sinra is also a member. So you can always go to the website and see all the members that have joined. But we're pretty excited about the future of LoRaWAN. As of the start of Q2, the LoRaWAN technology has now been deployed in roughly 157 countries, with about 137 or more operators that are deploying across the world. We had seen about 135 million end nodes that were deployed across the world by the start of Q2 this year, and roughly 800,000 gateways. And what gateways are basically the means for the device to communicate data into the cloud, and those get deployed on infrastructure, massive tower assets or rooftop assets. So we've seen a massive growth there. As of recently, this past week, the LoRa Alliance has launched or published their latest technical specification, which is the 1.0.4. And they also released their latest regional parameter specification, which is 1.0.2. And this encompasses a lot of new countries, a lot of new things that we're looking at from FOTA, firmware over the air, security. We heard Gaurav talk about their certification process. The LoRa Alliance also has a certification that they put devices through around the world, and they give it a stamp of LoRaWAN certified. And as he mentioned as well, you should have the confidence when you deploy these devices in the field if they've gone through those certification processes. And you can kind of think of that as something even back with electronics, HC units, stoves, washer and dryers. They all have their 5-star ratings or that kind of thing. And IoT devices are now starting to come into that space as well, where certifications really do need to take place in order to build the confidence of the consumer, the enterprise, as well as the government. So we're seeing some really good success there. The LoRa Alliance has launched a showcase page on their website where all the members that are developing solutions, end-to-end solutions, software, LNSs, the network servers, even the hardware, you can go to their showcase page and see from a hardware perspective, they only advertise the certified products as a way to ensure the quality. I started Sinra in 2017. Jim mentioned he is seeing India as the 3rd largest region in the world from an LPWAN perspective. I had saw the same thing when I was looking at the numbers back before I decided where to deploy Sinra. I had picked either Middle East or India, and based on the massive smart city mission program, the Make in India efforts, the digital India transformation that's going on, I thought India was the right place, and it looks like I made the right call. We're very, very excited about the future of IoT in India and the LoRaWAN technologies leading the way. LoRaWAN, from a smart city perspective, we're seeing about 70 to 80% of the requirements are being met by the low power wide area network technology. And so that's a massive market in itself. And we feel that LoRaWAN will probably sit within 60 to 70% of the overall LPWAN market, sitting toe-to-toe with NB-IoT if you look at the broad spectrum. We also heard from Gaurav talked about zero-G, and you mentioned what that was. So we are looking at a similar thing from a LoRa Alliance perspective, which is zero touch. And what that means is, how do you deploy a device with minimal interaction in the field, in a minimal setup, and minimal maintenance and upkeep. So reducing that operational energy to be able to deploy devices, leave, forget about it, and just let it do what it's supposed to do. So that's a really big thing that we're looking at in the LoRa Alliance, to try to figure out how we can get to that place where humans and machines live symbiotically, and really do the best thing it can for the citizens. So that's kind of the background of the LoRa Alliance. From a Sinra perspective, we've deployed our infrastructure in India in 76 cities now. We've got network coverage from north to south to east to west. We're doing projects across the spectrum of IoT segments, from agriculture to metering, to animal tracking, from industrial IoT of asset tracking. We're doing projects in the railway space, a lot of things in parking, smart city related activities in general. So there's a lot of opportunity to grow. COVID itself has also created a movement now. So when it started in, I guess in India, we started seeing March, when the lockdowns really started kicking in. And globally, the economies were starting to feel a little bit of strain on their businesses and revenue generations. Well, what did that do is it created this urgency of digitalization that has pushed companies and businesses and enterprises, I think, almost 5 years forward, which, if COVID wasn't here, it probably wouldn't have occurred. If you look at the overall history of pandemics, even dating all the way back to the 19th century, you look at the cholera epidemic, the bubonic plague, the smallpox. These type of pandemics have created a movement of urbanization and rethinking the complete infrastructure and architecture of cities. And normally what will end up happening is there is technology and innovation that comes into play in order to push society to a place where they can be safe and their humans can be safe from these type of diseases. In New York City, for example, in the late 19th century, the way they had built apartment complexes had no ventilation. And so they had to redesign how to build apartment complexes that created airflow. In the late 19th century, Bombay got hit pretty bad by the bubonic plague. And what was the reasons behind that? Fresh air, the hygiene, and proximity issues. So we hear a lot about proximity now in 2020 from a COVID perspective, and IoT is starting to take these technologies that Sarjit had mentioned with Tata Steel on the tracking capabilities, and creating the analytics with the same devices to be able to determine not only where they are, but who they have been in contact with, tracking their historical medical records from the time that they get sick to the time that they're better, and also the distance from where one person and another person has been. Not only were they within 6 feet, but were they within 6 feet for more than 15 minutes, which then increases the chances of getting COVID. So ironically, with economy struggling and dropping, COVID-19 has been a blessing from a digital perspective and a movement of more innovation and creative in the IoT space. And I do see LoRaWAN playing a big play there.
Thank you. Thank you, Ali. Just one quick question, Ali, especially from a COVID standpoint, if you quickly if you can share a use case, say around people counting or social distance adhering. So if you can just share one or two cases, that would be great.
So what's funny is I think Sarjit nailed it on the nose when he mentioned that just one technology won't solve the problem, that you have to use multiple technologies to really come with a complete end-to-end solution. We explored leveraging LoRaWAN from an end-to-end perspective, not using any other technologies at all, and trying to do this proximity contact tracing solution offering. What we quickly realized was in India, price is very sensitive market, and some equipment that you could use, which was other technologies with a hybrid integration of backhauling over LoRaWAN, was actually a more cost-effective approach. So leveraging RFIDs, leveraging BLEs, beacons, these type of technologies enabled the LoRaWAN infrastructure and the LoRaWAN capabilities to come in and provide long-range, long-distance backhaul communication systems. We've talked to institutions, we've talked to colleges, we've talked to public schools, private schools, and those were their main concerns was, well, our budgets are low, we can't really spend that much on these fancy devices. But we do want to take care of our employees, our staff, as well as our students. So what can we do? So we spend a lot of time from an R&D perspective just researching and developing, thinking, reaching out to companies that are in spaces that we never really touched on, like Bluetooth, for example. And we ended up coming up some really good solutions where, either if it's a wearable or if it's a badge or something you can stick on a book bag or in your pocket, similar to what Sarjit's video showed, you can just now leveraging Bluetooth beacons, RFID readers, and then these retrofitting devices that go into, for example, our RFID reader. We've done something with an RS-232 port where there's a module that transmits on LoRaWAN. It plugs into the reader 232 port, and then it just takes the data and transmit over long range and long distances. So those have been pretty successful for us. But we couldn't have done it without our partners. We're a network operator, unlike Sigfox, where they have control of the end-to-end processes and development. Obviously, with their partners that they contract, the LoRa Alliance is meant to let anyone come and develop and build whatever they want. And from the stack perspective of the ecosystem, we focus heavily as a network expert and the RF piece of things. So we had to rely on partners that were developing products around the world and then doing price comparisons and trying to figure out, what really works for India versus the Europe market or the North America market.
Thanks, Ali. I want to take a question from the audience, and I'll address this to Jim. And Jim, this question is from Sachin Kumar Agrawal from HCL Technologies. So his question was around 5G. With perhaps we'll have 5G in India in maybe a couple of years from now. So how will LPWAN kind of work in conjunction with 5G? Will this propel growth of LPWAN once we have 5G in India, Jim?
Well, yes. So 5G is a new and wonderful thing. There are three main components of 5G. One of them is about enabling very high bandwidth communications, higher speeds than 4G and LTE. And another element is ultra reliable, low latency communications, and that's very small data packets, quite likely within a private network, a scenario which are guaranteed to arrive. So you can have things like an industrial machine, and you can have a remote from that, hand control, which is connected over 5G, and you can have an emergency stop button, and it's guaranteed to work in real time. That's URLLC. The other component of 5G is massive machine type communications, and that is LPWA. And that element of 5G is in fact two elements of what we currently have as 4G, but included in the 5G standards. So on the air interface side, there's no change. There's changes in the network side, but on the air interface side, there's no change. So right now, what we have is we have NB-IoT, which is live as a 4G technology, and we also have LTE-M, which is live as a 4G connectivity technology, and those are basically lifted and dropped into 5G. So it's crucial to remember that parts of 5G are already with us in 4G.
Okay, great. So Jim, you mentioned India third number in terms of
Yes.
LPWAN connections, maybe 5 years from now, right? And so you see a coexistence of both the licensed technologies like NB-IoT as well as LoRaWAN solutions, Sigfox solutions. So you see this whole ecosystem expanding, right? I mean, it's not one replacing the other, but rather all coexisting together, because that's only going to expand the market, right, Jim?
Absolutely, yes. And at the end of my presentation, you asked me of the split of the numbers, and I dropped off I dropped off. Well, I was listening, but I dropped off video quickly just to check those numbers. And worldwide, at the moment, about 45 to 50% of LPWA connections are MMTC versions, so 5G licensed versions. A lot of that is skewed by the rate of adoption in China. A lot of those worldwide connections are in fact in China. The figure for India at the moment is significantly lower as lower MMTC proportion. If you spin forward to that point where you asked me in 2026, when you have more licensed than more LPWA connections than cellular non-LPWA connections, about 2/3 of those worldwide will be the cellular versions of LPWA, so MMTC and NB-IoT, and that in many ways is because of the homogeneity of that environment. And particularly in the domain of consumer devices, where NB-IoT, for instance, is offered by multiple cellular operators worldwide. There's still some issues in terms of roaming, but broadly speaking, you've got a more homogeneous global network there, which helps with some of the high volume devices, the consumer devices. The figures in India are a little more skewed towards unlicensed than globally, and potentially that's probably potentially a lot of that is to do with more campus style deployments. So a dockside, for instance, where you want a potentially a LoRa network popped up within a dockside to track everything, all of the devices within there, the comings and goings of the people, the usage of infrastructure, etc., and charge people for the use of infrastructure and provide access to different areas of the docksides. So those kind of private network solutions are probably likely to be more significant in India than potentially worldwide as a proportion.
Thank you, Jim. Sarojit, this question is very India specific, Sarojit. What in your view will really propel the growth of LPWAN, and more specifically, what will drive more IoT adoption in India? Sarajit, if you can briefly share, that will be great. You have kind of set a benchmark. Tata Steel has set a benchmark in terms of digital maturity. So, how do the others take a cue from you and really accelerate their digital transformation journey, Sarajit?
What will drive growth is what I call a business technology roadmap. What typically happens is there's a bunch of technologies saying, look, this is a device, this is a connectivity. There's another bunch of pure physicists saying, you know what, you need to understand that this is latency. And somebody will come up and say that, there's an equation to latency. It is distance to satellite divided by the speed of sound, light, distance back from satellite into number of hops. It's a formula. And you get into all those, and then you try to get into standards formation, and then you get into what will really drive in our mind is to keep it really simple. Find out a use case, a very sharp use case, which is very valuable. Somebody is standing behind it to really, it's some problem. Fall in love with the problem and not with your solution. Create a business case. The business case will always trump the model, or as I'm often told, I'm a techno-determinist, I'm told. In my own case, my passion case for technology, business will always trump. The business case will always trump. The rest of it will all follow. So once you find, and I like what Jim says, people have to find out their campus style deployments, and the campus can be as small as a cottage industry, or the campus can be 25 square kilometer for Tata Steel. Does not really matter. Or it can be 400 square kilometer for the state of NCR. The point is, you need to be very clear. Start with the basics. Use case, come to business case, come to a user experience. The rest of it is just boilerplate in my view. We start from the other side and say, here is the deployment, here are the technologies, here are the standards. Everybody runs away and keeps doing their job. Sorry, it's just my view, but...
No, fantastic insights, Sarajit. Peter Drucker once said, culture eats strategy for breakfast. So perhaps business eats technology for lunch, perhaps. As you said, business is far more. Okay, over to you, Gaurav. Sorry, I had to interrupt you earlier, but from an India standpoint, how do you see, Six Fox plans, and what do you think will propel really the IoT adoption?
Sure. So, going back to what I was talking about earlier and in my earlier part of the conversation, what we're seeing essentially in India is a replication of what use cases we have seen from our global operator community, right? We have currently in our global operator community close to about 3,000 live projects that are ongoing in different vertical segments. And, we have the ability, therefore, to actually cherry pick, the most mature and the most commercially market ready solutions in terms of the opportunities that we see in India. So and the ability to kind of reconcile the opportunity in India from our own assessment with this treasure trove of solution architectures that is available to us from our global community, which includes, by the way, the device and the platform and the application. And so in India, we are seeing a huge amount of opportunity in the asset tracking for industrial application space. We are seeing, the opportunity for predictive and prescriptive maintenance from a manufacturing, plant perspective. We are also seeing container tracking opportunities across the length and the breadth of the dedicated freight corridors and industrial corridors of the country. And then we are seeing some very strong demand building up, though, like Ali and I were talking about a little while earlier, building up in the utilities segment, specifically for smart metering, AMR and AMI kind of applications. However, the real upturning of this will come from the ability of, like everybody on the panel talked about devices, being able to actually open source these device architectures, because really these devices are very simple sensors, right? I mean, and these should be, they should follow the same path that the internet followed, which is essentially that today the internet is so prolific, primarily because of the contribution of the users and not because of the companies that develop the content. So there's a bottom-up overturning happening in the internet industry, which I think will also drive the IoT industry going forward, where, we just came off for 2 days global Sigfox event, which ended yesterday. It was, well attended. But one of the key presentations and moments for me was when Google architect came up online, and he talked about this new architecture that we have developed with Google on the edge, which will allow us to do machine learning for very high semantic data feed, which is essentially a high resolution camera capturing traffic information. And the Google machine learning edge processing unit can convert that very high semantic, high bandwidth data into bits and bytes that can then be sent over the Sigfox network in terms of just the inference that you draw out of that camera in terms of whether vehicle counting or people counting or what have you, right? And these are game changers, right? And by the way, all of this is available on GitHub as a downloadable open source architecture that any company out there interested in entering this space can download, get the source code, which will enable you to set up not only the machine learning capability, but also the connectivity to Sigfox and then onwards to the Google Cloud. So these are kind of game changers that we can influence because, Sigfox has built and incubated a global community of operators and partners on either side. And in India, we hope to be able to accelerate that time to market, leveraging and exploiting all of these assets that we've created globally.
Thank you, Gaurav. There's time for just one last question, and this question would be for Ali. There was a question posed regarding a use case for LoRa in agriculture industry. Ali, if you have any use case that you want to share.
Yeah, so we've done projects in agriculture space. One of our customers was a massive tobacco manufacturer, farming company. The specific use case ended up saving them, I believe, 30% ROI on their return. And what they did is they had a company that they contracted that had used temperature sensors and humidity sensors. And they leveraged LoRaWAN, us, to provide the network connectivity in a place that had about 80 farmers within a village. And this farmland, what they would do is they would curate the tobacco. So they'd hang it, they'd dry it. And it's a very critical point in time where they have to determine when the tobacco is ready for the next step in the processing. And at that point in time is when this big tobacco manufacturer would come and purchase the leaves from the farmers. So what the manufacturer wanted to know was when they're buying the leaves, is it actually at the right stage of curation in order for them to maximize the quality? So we were able to put one gateway in a place that had coverage for 80 plus village farmers. And they deployed a sensor per farmer where they were hanging their tobacco. And it was a very successful project, and it's been ongoing. So it's a seasonal type of project. So this gets re-engaged over and over again over a certain amount of time during the right growth period. So in that space, we've seen a lot of great stuff. We've been able to coverage national reserve parks for tiger tracking, which is similar to smart ag, but more so into animal tracking. But what the point is the network coverage can create a umbrella of coverage in these remote areas where cellular connectivity is not the greatest, or internet is not available in a lot of places. And so that's been real successful in the ag space. To talk about some other things, we have contracted over 200,000 water meters to be deployed throughout India. And we're currently doing the largest LoRaWAN water meter deployment in India to date in West India. And I think right now they have 1,000 of the meters installed, but they're deploying hundreds of them every week. And at the end of the scope, it's going to range from 10 to 20,000 water meters in an entire city. So we've lit up an entire city with our network coverage, providing connectivity there. As Gaurav mentioned, we were talking about utilities. The utility space is becoming the anchor project for LoRaWAN for us as an operator. What you do is you're getting massive amount of device connectivities on our network, and the network then gets deployed. And what's great is the next solution, the next project, the next smart parking or street lighting activity that's going to take place in that same city. The infrastructure is already deployed and covered, and what you'll start to see is rapid deployment and the deployment to get much, much faster over time. There was a question that was talking about electricity meters, I believe, in the IPv6 requirements. The LoRa Alliance formed a partnership with the DLMS, and they just released a paper on how LoRaWAN can support IPv6 while it integrates with DLMS and the SHIC layer. So, Mr. Jain, if you go to the LoRa Alliance's website, you'll be able to actually see that information and download the paper. Overall, and no one's ever made this statement before, but I'll go ahead and do it. As of February to March, I was projecting, based on my math, over 1 million LoRaWAN devices have already been either deployed, under contract, or planned to be deployed this year. So it's a massive, massive growth that we've seen from 19 to 2020, and I expect it to just keep going.
Thank you so much, gentlemen. Sarajit, Gaurav.
Sunil, can I just get one last word in? And this is in response to Rajdeep Banerjee, who's got a question.
Yeah, I was about to ask you that, Gaurav.
Okay.
Yeah, so sorry, Sunil.
Sure. Go ahead.
Just very quickly, so thanks for the question, Rajdeep, and this is an important point that I should have indicated earlier. So we are right now already licensed. We received our license from the DOT in the middle of October to operate a nationwide M2M network, and we are now in first week of January expecting to start our deployment aggressively. To begin with, we will cover in phase 1, which is about 6 months. We will deploy about 1,300 base stations to essentially cover all the tier 1 cities, as well as all of the highways, the warehouse clusters, the dedicated freight corridors, industrial corridors, etc. And if there is some interest, we could always set up a time to talk later. Over to you, Sunil.
Thank you so much, Gaurav, and it's been a pleasure moderating this panel. I'll just take a minute to sum up. So I think there are enough drivers now for IoT adoption in India to really pick up, because one is the technology is getting even more democratized. The cost of moving data to cloud is lower. Cost of devices are coming down, and it will probably come down even further because there is this big initiative to make many of these in India. The cost of connectivity is obviously much, much lower compared to any other part of the world, and there are many more options now for connectivity. And I think the whole premise that today IoT is just not a nice to have but a strategic necessity, because you need it for your survival and growth. So I think that is definitely going to propel IoT adoption in India. Thank you so much, gentlemen, and thank you, Suman, for this opportunity to moderate such a fantastic panel. I just hope the audience enjoyed the discussion. Over to you, Suman.
No, thank you so much. I think, Sunil, it was a top job, moderating this session, handling such tough set of panelists, and a topic like this. I think all of you did justice to it, completing the discussion and covering the topic in its entirety, like I was mentioning earlier. All of you have a great weekend. Thank you, all the speakers.